click the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hi guys, welcome to Smart BCAD video tutorial on the course Reliability and Maintainability. Today we'll be talking about reliability prediction. The course Reliability and Maintainability is a very practicable course because in the field of engineering you have to know whether your system is reliable or not. You have to know the percentage of its reliability for you to give your consumers or your customers guarantee or warranty. So today we'll be talking about reliability prediction, and here reliability prediction, this is the process of calculating the anticipated system reliability from assumed component failure rate. So here what this is trying to say is that we are going to assume some component failure rates for us to know if the system is actually reliable or not. So if, for example, if you design a system, for example, so all its components you are going to assign a failure rate to them. So after that you can calculate the total value of the total amount of reliable, if your system is actually reliable, if it meets the criteria. So for us to do that, we have some types of system that we have to look at. So firstly we will be looking at series system. So it is the normal series that you know, series system. So let's say, for example, so we'll be looking at the types of system that we are going to be studying. We have the series system. So these are systems in which the failure of one unit or subunit means the failure of the entire system. So what this is trying to say is, let's say we are having three components connected in series to make up a particular system. So let's call this component A, let's call this component B, and the last component C. So this is our input and this is our output. So what this is trying to say is, if any of these components should fail, the entire the entire system will definitely fail. For example, if component A is faulty, the entire system will be faulty. If component B only is faulty, the entire system will be faulty. And if component C, so the failure of one unit or subunit means the failure of the entire system. So the reliability of the entire system will be R of A, B, C will be equal to reliability of A multiplied by the reliability of B multiplied by the reliability of C. So therefore, which means, you know, multiplication rule, if you should have 1 to be equal to 0, definitely everything will be equal to 0. So this is the probability of a series system. So now let's move to the parallel system. So for parallel system, these are systems in which the whole system does not fail until all the entire subunits has failed. So you see, the reliability of a parallel system is more reliable than a series system, which means if you're having three components, what this is trying to say is, if you're having three components connected in parallel, so assuming these three components are these three components are connected in parallel to make up a particular system, let's call this component A, component B, and component C also. This is our input and this is the output. So what this is trying to say is, if component A should fail, the system will still operate because it has another root, which means it has component B and component C to also work. So if component C should fail, the system will still work. So for this system to fail, the entire component in the system must fail. So that is the reliability of this system. So this is utilizing the additional law, which says that reliability of A, B, C is equal to reliability of A plus reliability of B plus reliability of C minus reliability of A multiplied by reliability of B multiplied by reliability of C. So this can also be further represented as 1 minus open bracket 1 minus reliability of A multiplied by 1 minus reliability of B multiplied by 1 minus reliability of C. So this is the expression for parallel system. So one thing you should know in this parallel system is the failure of one component, one or two components, doesn't mean that the entire component, the entire system will be faulty. It is only faulty when the entire component in the system is faulty. So now let's move to the last system that we're having here, the series parallel or parallel series system, which is also known as the hybrid, since it is both the combination of series and parallel system. So these are systems which, if one of the subunits in the series fail, or these are systems which fail if one of the subunits in the series fail, or if the entire parallel subunit fail. So what this is trying to say is, let's say we are having three components. Let's continue using our three components as an example. So let's say we are having component A connected in series with components B and C, and component B and C are in parallel. So you can see this is an hybrid system. This is a series parallel system because we are having component A connected in series with with component B and C, but component B and C are in parallel. So this system will only fail if the component A is faulty, because it is connected in series with component B and C. But component B and C this system will also fail if the entire component connected in parallel, which is B and C, fails. So this is straightforward. It's just like combining the two laws together. That is what is happening here. So the expression for this is still the same thing. So for example, let's say here we know that the probability of here is R A, right? The reliability of BC we can say is 1 minus open bracket 1 minus reliability of B multiplied by 1 minus reliability of C. So this is the expression for this. So since these two are connected in series, then we multiply them. So the total reliability now will be equal to reliability of A multiplied by 1 minus open bracket 1 minus reliability of B multiplied by 1 minus reliability of C. So you can see here we are combining the two laws together to get the final reliability. So that is all for types of system. We also have the parallel series. This hybrid system, they can be connected in different ways. So I hope you enjoyed this tutorial. In our next class, we will start solving examples on reliability prediction. So please stay tuned and subscribe. Don't forget to subscribe to our YouTube channel. We'll meet in our next tutorial. Thank you.